Hey everybody, we're doing parallel and perpendicular lesson number 6 today, and if it seems like you did this in Algebra 1, it's because you did this in Algebra 1. Now we're talking about just equations of lines, graphs of lines, all that good stuff. And we start with just a basic idea of slope, and that is ultimately the thing that's going to relate to parallel lines. The idea that if two lines have the same slope, if they are going up at the same speed or down at the same speed, they will be parallel unless they are the same line. But that's another conversation entirely. But anyway, we can't do the parallel or perpendicular lesson number 7 unless we understand what lines are, how the slope decides what the line is going to do, all that good stuff. So we start with just a basic definition that slope is how fast or how slow a line is going up or down. Now, I always tell people that you need to read a line like you read a book. I see so many people who make sign errors when they're talking about slope. It's because they're not actually judging what the line is doing from left to right. Now, the phrase that most people have heard, the rise over run phrase, some teachers aren't big on that phrase, but I think it works. I think that's not a bad way to keep track of what's going on mentally, and so I will refer to it, and I don't mind that at all. Now, when we're talking about looking at a line and finding the slope, you need to just find a couple points that work for you, and it doesn't actually matter which points they are. Like if I were to look at this point right here and this point right here and ask myself what it would take to get from one to the other, first of all, from left to right, this line is going up, meaning the slope is going to be positive. So you are going to, if you want to go from one point to the other, rise 2 and run 1. That means 2 over 1 for the slope, but we're never going to call it 2 over 1. We're better than that. We're just going to call the slope 2. Now, this is when people ask, well, what if you chose different points? Would you still get the same answer? Well, yeah, you still would. If I went all the way down here and then I went all the way up here, you would end up getting up 10. That would be your rise, and over 5. So you would end up getting 10 over 5, but 10 divided by 5 is still 2. So no matter how you break it up, the answer is 2. Now, this next example looks exactly the same. The only difference is if you read a line like you read a book, you will find out that it is going down from left to right, which means the slope will be negative 2 instead. Now the third one, it is going up from left to right, but it is not going up very fast. So we need to think about it. If we're going in terms of rise over run, now the rise would be 1 and the run would be 2. So if we're doing rise over run, now we're talking about a slope of 1/2. Okay. And even if you had picked different points, again, we could go here and we could go here. The rise would be 3, the run would be 6. So either way, you're going to be getting 3 over 6, which would reduce to give you 1/2 anyway. So it doesn't matter. However you break it up is fine. It doesn't really make a difference. All right, now this is where I am going to differ from a lot of teachers here. Because if you don't want to use rise over run, or if you can't because they didn't give you a graph and you have to find the slope, most teachers use the formula. And they say, here is the formula for slope. I'm not big on the formula because I think counting is better. Anytime I have been able to, in my teaching history, turn something into a counting drill, people do better. That's just historically what I find. So I'm going to go with my gut. I'm going to go with what works best for me, and I'm going to teach you to count. So I just want you to ask yourself, if you were to go from -1 to -3 on a number line, did that number go up or down? Well, it went down. You went from -1 to -3. How far down did it go? Well, you went 2 spaces down. So again, if you were to think about a number line, and this is 0, -1, -2, -3. To go from -1 to -3 on a number line, you had to go back by 2, so -2. All right, so what about if you had to go from 8 to 16? Well, on a number line, you would just have to make 8 jumps up. Slope is the second number divided by the first number. And the reason is, these are your y's, and when your y value changes, you are rising or falling. These are your x's. So every time your x value changes, you are running. You are going from left to right. So you get -2/8, and that reduces to give you -1/4. Always use the reduced answer when you're actually coming up with your final result here. Now, you look at the next one. If I were to go from 21 to 1, well, I had $21, now I have $1. That means I just lost 20 bucks. All right, now from -4 to +6, well, I was $4 behind. Now I have $6. That's actually a $10 difference because I needed $4 just to get back to 0, and now 6 more would give me 10. So -20, again, rise over run, the second number divided by the first number. So -20 divided by 10, which would give you -2. All right, last but certainly not least, if you were to go from 7 to 4, you went down by 3. If you were to go from 3 to 5, you went up by 2. So the slope is -3/2. That's it. It bothers me that people overthink slope and they have to make a formula out of it. Don't worry about it. Think, how much did your number rise or fall? How much did it run? And then rise is the second number. Run is the first. All right, now, one other thing here. We're going to get to point-slope form. And I have met a lot of people who think point-slope form is somehow complicated. It's really not. In fact, it's the slope formula just written differently. That's really all it is. And let me prove it to you real quick. Let's say, and don't write this down under here where it says examples. I'm just doing a quick demonstration here. Let's say you put this over 1, and you went middle school style, and you cross-multiplied. Okay, in middle school, a lot of middle school teachers teach you to cross-multiply, and I think you're used to it. An example in middle school would be if you had like 3/5 equals 9/x. A lot of teachers will teach you to cross-multiply. You would just go 9 times 5 and 3 times x. Anyway, that's what I want you to do here. Just a little old middle school trick. Okay, so I want you to do 1 times that. Well, when you multiply something by 1, it doesn't change, so we'll just leave it. And then I want you to do m times this. Okay. And then I want you to erase the 2's. Again, you don't have to write this. I just kind of, if you wanted to go through this demo, you could see. Well, look at that. We just created point-slope form. You see, the slope formula and point-slope form are the same formula, just written 2 different ways. So if you've ever seen a teacher and they make you memorize the first one and they make you memorize the second one, that's not really valid. You don't have to do it that way. Anyway, I like doing that demo because I like people to see that these things are related. It wasn't just your teacher telling you memorize. No, they're related to each other. All right, so whenever I teach point-slope form, it's short and sweet. I say y minus blah equals blah times the quantity x minus blah. I always teach it that way because I want kids to remember point-slope form is not scary. There are 3 things that you need to plug in. So plug in those 3 things. Okay? M is the fancy letter that we use for slope. Now, we already know the slope between these 2 points because I already gave it to you as one of my earlier examples. See? I didn't just pick those numbers out of the blue. We already did that. The slope is negative 1/4. Now, the numbers that you want to plug in for x and y, you just have to pick a point. It doesn't even matter which point you pick. If you look at the first point, for example, the x value is 8 and the y value is negative 1. So I'm going to put the x value next to the x, and I'm going to put the y value next to the y. Oh no, 2 negatives, what do we do? Well, 2 negatives, a negative times a negative, you're going to get a positive. So just change that to a positive. Now, your default, if I do not specify, your default should be to actually work through this and make it into slope-intercept form, the one where y equals. Now, technically, if it just says find the equation, technically that is an equation. But for me personally, I want you to get it to slope-intercept form. I want you to find a way to get y by itself because that is going to be the most common form that you are going to see in the future. In order to do that, it's only 2 steps. It's really not that bad. Negative 1/4 times x, we're just going to distribute. So that's going to give you negative 1/4 x. And then here we're going to distribute. A negative times a negative is a positive. And 1/4 of 8 is 2. Now, there's one last thing that needs to be done to get y by itself. Really not that big of a deal. All you have to do to get y by itself is subtract 1 from both sides, which means y is going to equal negative 1/4 x, and then 2 minus 1 is 1. Okay, there you go. So again, in my class, I expect you to write your final answer in slope-intercept form. If I do not specify, I expect it to be that way. It's going to be the most common way to go. When you're using a graphing calculator, a lot of times they want it in slope-intercept form if it's a TI 80 whatever. So it's good practice. All right, next one. We already know the slope that we are going to use because we calculated it earlier. So let's set things up. Y minus blah equals blah times the quantity x minus blah. Point slope form only has 3 things, so go with it. Now, we already know the slope. Like I said, we figured it out earlier. I used the exact same numbers in a prior example. The slope is negative 2. Now, again, it does not matter which point you pick. I'm going to pick the first point. I'm always going to pick the first point. That way, nobody ever has to ask me, hey, Mr. Ben, why did you pick this point? That's just me. So, I'm going to put negative 4 right here. Oh no, 2 negatives. Make it into a positive. And then I'm going to pick 21 for my y value. So again, I'm using the first point. So that's going to give me negative 2x if I distribute. So negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. And then the last step in the process, I'm going to have to get y by itself, which means I'm going to have to add 21. And that should give me a final answer that I'm looking for, and it's going to be y equals negative 2x plus 13. Negative 8 plus 21 is 13. Okay. So we got one more to go. This one is just a little bit weirder because of the way the fraction breaks down. So you got to be pretty comfortable with fractions if you want to be successful here. So let's see how we do. Y minus blah equals blah times the quantity x minus blah. So again, there are only three things to plug in. You look up here, we have a slope of negative 3 over 2. Again, not a coincidence. We already used that example, so we might as well just save ourselves the time. And then I'm going to just pick the first point because I always pick the first point. The x value of that point is 3. The y value of that point is 7. So now I'm going to distribute. That's going to give me negative 3 halves x. A negative times a negative is a positive. And then if you want to distribute the 3 halves with the 3, you treat the 3 like it's a 3 over 1. So you're going to multiply the top by the top, the bottom by the bottom. So you're going to get 9 over 2. From there, you're almost done. You just need to add 7 to both sides. So that's what we're going to do. We're just going to say plus 7 and plus 7. 9 halves plus 7. That's going to be one of those where you're going to have to go old school here. You can't add or subtract unless you have a common denominator or a calculator that'll do it for you. So when it's time to add, I'm going to look at that 7 over 1, and I'm going to say, well, I can't add or subtract unless I have a common denominator, so I'm going to multiply that by 2. Whatever you do to the bottom, you got to do to the top. So this actually becomes 14 over 2. And 9 over 2 plus 14 over 2 is 23 over 2. Now, if you don't like any of that and you called it 11.5, I'm okay with that. My only deal is, if you're going to use decimals, I want you to be consistent. I don't really want you to use a fraction for slope and then a decimal for the intercept. That just seems kind of weird to me. I would rather you be consistent one way or the other. Anyway, I hope this helps you out, and I will see you next time.